This is the seventh class of manufacturing process, module 1. In this section, I am going to discuss about die casting process and centrifugal casting process. First, I am going to discuss about die casting process. Die casting process is considered as a permanent metal mold casting process. Entire casting process are classified into two types: expandable mold casting process and permanent mold casting process. In expandable mold casting process, after the casting has been get solidified, the entire mold is destroyed and the casting is taken outside. There is separate mold for each individual castings. In permanent mold casting process, there is a permanent metal mold which is used for producing thousand number of product. Die casting process is a permanent mold manufacturing process which has wide application in manufacturing automotive components in automobile industry. First step in a die casting process is production of a metal mold which is accurately created by using machining operation. Two halves are making by some sort of machining operation and which can be open and close by using some mechanical method. See, while building the die casting mold, gating system also uh, machined inside die casting mold. So die casting process are classified into two types: hot chamber die casting process and cold chamber die casting process. So two classification of die casting process are cold chamber die casting process and hot chamber die casting process. First of all, cold chamber die casting process. See, this is a schema diagram of cold chamber die casting process. In the case of cold chamber die casting process, the molten material is preparing separately in a furnace. Then it is poured into a short chamber with the help of ladle. Initially, the molten material is carried from the furnace by ladle. From ladle, the molten material is poured into a short chamber. A fixed quantity of molten material that will be poured into the short chamber, and after that the plunger that will exert a force over the molten material. The molten material is injected into the metal mold. Then solidification takes place. So in cold chamber die casting process, the molten material is preparing separately in a furnace and it is taken, a fixed quantity of molten material that is taken in a ladle and poured into the short chamber. And during cold chamber die casting process, the plunger that will exert a force over the molten material, the molten material is injected into the mold cavity. So after the casting has been get solidified, the mold open and the component is ejected. In hot second classification is the hot chamber die casting process. See, this is the figure of hot chamber die casting process. See, in hot chamber die casting process, all the pumping elements are completely immersed in the molten material. See, the mold is placed very near to the molten material. The pumping elements, so these are the pumping elements, and this is plunger rod, plunger, short chamber, and there is a intake port. So all the pumping elements are completely immersed inside the molten material, and the mold that is placed very closely to molten material. So initially, the plunger that will be moving in upward direction through intake port, the molten material flow into hot chamber. So during the casting process, the plunger move in downward direction, sealing the intake port and exerting a pressure over the molten material. Molten material flow into the mold cavity through this path that is known as gooseneck. This path is known as gooseneck. So the molten material that will be flow into the mold cavity through gooseneck. Then the molten material fill the mold cavity, solidification take place. After solidification, the mold will be opening and taking the casting outside. So this is happening in the case of hot chamber die casting process. So what's the difference between a cold chamber and hot chamber die casting process? In cold chamber die casting process, the molten material is preparing separately in a furnace. In hot chamber die casting process, the entire pumping elements are completely immersed inside the molten material and the mold is placed very close to the molten material. So that's the main difference between cold chamber die casting process and hot chamber die casting process. So difference between cold chamber and hot chamber die casting process. So this is very important. There is a chance that in university question this may be asked, difference between compare cold chamber die casting and hot chamber die casting process, etc. So what's the difference between cold chamber and hot chamber die casting process? So cold chamber die casting process and hot chamber die casting process. So first of all, molten metal for the casting is introduced into the short chamber from external source. In cold chamber die casting process, the molten material required for the casting is introduced to the short chamber from external source, from a furnace. It is taken in the ladle. Okay. In cold chamber die casting process, source of molten metal attached to the machine. Source of molten metal is very close to the mold. It will be automatically flowed to the mold through gooseneck. Second one, cold chamber die casting process, which is used for high melting point alloys. Aluminium, brass, copper, aluminium, zinc are used in cold chamber die casting process. Hot chamber die casting process are commonly used for low melting point alloys. Because in hot chamber die casting process, the pumping elements are completely immersed inside the molten material. If the temperature is very much high, it will cause problems to machinery. So lower melting point alloys are commonly used in hot chamber die casting process. See, in cold chamber die casting, material must be brought in for a very short or cycle of production. This slow down the production rate. So in a cold chamber die casting process, every cycle material has to be poured into the short chamber. So it will always slow down the production rate. In hot chamber die casting process, the entire pumping elements are completely immersed inside the molten material and the molten material is automatically pumping into the mold cavity through gooseneck. The casting can be constantly output. So these are the difference between cold chamber die casting process and hot chamber die casting process. Okay. So in cold chamber die casting process, molten metal for the casting is introduced in the short chamber from external source. So in hot chamber die casting process, source of molten metal attached to the machine. Cold chamber die casting process are commonly used for high melting point alloy. Hot chamber die casting process are commonly used for low melting point alloy. Cold chamber die casting process, in every cycle, the molten material should be introduced to the short chamber. So the cycle of production will be less slow production. But in hot chamber die casting process, it have a constant output. Okay. Okay. So next one is the centrifugal casting process. Very important type of casting process, centrifugal casting process. See, centrifugal casting process is basically a permanent mold casting process which uses force generated by the centripetal acceleration to distribute the molten material in the mold. That's an important point related to centrifugal casting process. In centrifugal casting process, force generated by the centripetal acceleration is distribute the molten material in the mold. So there are three types of centrifugal casting process: true centrifugal casting process, semi-centrifugal casting process, and centrifuge casting process. So we can discuss one by one. what's the concept of true centrifugal casting process, semi-centrifugal casting process, and centrifugal casting process. So first of all, true centrifugal casting process. So this is a figure of true centrifugal casting process. See, in true centrifugal casting process, the mold is rotated by rollers in horizontal direction or vertical direction. So this figure shows the mold is rotated in horizontal direction. On rotating mold, a fixed quantity of molten material is pouring. So due to the centrifugal force, the molten material are flow in outward direction towards the mold wall. So the molten material that will be pouring into the mold while the mold is rotated, or after the fixed quantity of molten material is poured into the mold, the rotation will be starting. So in a true centrifugal casting process, so this is a mold in the true centrifugal casting process. It will be either rotating in horizontal direction or vertical direction. So a fixed quantity of molten material that will be pouring into the mold. Due to centrifugal force, the molten material that will be pushing in outward direction towards the wall of the mold, and solidification take place. The casting will be taken outside. See, in centrifugal casting process, the forces developed during centrifugal casting process will have a large role play. See, the force developed due to centripetal acceleration that will be acting in outward direction, and these forces have large value when the value of the forces will be increasing when the moving from center to the outward direction. So there will be large force will be acting over the molten material. It is away from the axis of rotation. Small force will be acting over the molten material where very near to axis of rotation. So nearby the mold wall, there will be large amount of force will be acting. But here in the nearby axis of rotation, center of axis of rotation, very small force will be acting. So high density material will be created in the top and low density material will be created in the bottom. And the impurities have less mass when compared to molten material. The impurities that will be accumulated here, that is nearby axis of rotation, and after the casting process the impurities can be removed by some sort of mechanism like grinding or machining, etc. So what's the important point is, due to the variation of forces that will be acting over the molten material, the force will be increasing when moving from outward direction. The large amount of force will be acting over the material which is very near to mold wall, and very little force will be acting over the material which is very near to axis of rotation. So high density material will be created, casting will be created in the outer region, and low density casting will be created in the inner region. And the impurities that will be always located in the inner region, that then the impurities can be removed by some sort of machining operation later. Okay, so this is high density region and this is low density region. The impurities will be located in the low density region. Okay, so this is the importance of a true centrifugal casting process. Second one is semi-centrifugal casting process. See, this is a figure of semi-centrifugal casting process. See, in semi-centrifugal casting process, the entire mold is completely filled with molten material through a central sprue, and after that the mold will be rotating. So this type of casting will be always used for casting that possesses rotation symmetry. So during semi-centrifugal casting process, the entire mold cavity will be completely filled with molten material. So a central sprue, then the mold is rotating, the casting will be get solidified, and this type of casting, semi-centrifugal casting, commonly used for casting have rotational symmetry. The last one is centrifugal casting process. In centrifugal casting process, the axis of rotation of mold and the axis of rotation of cavity are different. See, in semi-centrifugal casting process, you can see that the axis of rotation of mold cavity and axis of mold are same. Okay, axis of rotation of mold and axis of rotation of the mold cavity are same. But in centrifugal casting process, the axis of rotation of mold and axis of rotation of the mold cavities are different. So this is a figure of centrifugal casting process. See here, the cavities are located along a circle, and there will be a central screw which serve alternately into the cavity. So here, these cavities are located away from the axis of rotation. There will be large force will be acting over the molten material, and there will be the components will be high dense component, and the impurities that will be located nearby axis of rotation. So the casting, multiple number of casting will be produced, and the casting have high density casting will be produced as the casting are located away from the axis of rotation, and the impurities that will be located in the center. So what's the important points of centrifugal casting process is, here the axis of rotation of cavity and axis of rotation of mold are different. Multiple numbers of cavities are used in this process. Okay, so these are the three type of uh, centrifugal casting process: true centrifugal casting process, semi centrifugal casting process, centrifugal casting process. Then what is the advantage of centrifugal casting process? First one, casting require high density, high mechanical strength and fine grained structure. We can prefer centrifugal casting process. Inclusions and impurities are lighter, that can be removed later. Gate and risers are not needed. High output. Formation of hollow interior without using core. So these are the advantage of centrifugal casting process. And what is the disadvantage? An accurate diameter of the inner surface of casting. Inaccurate diameter of inner surface of the casting. Not all alloy can be cast in this way. Application for casting pipe, bushing, gear, flywheel, etc. Centrifugal casting process use. See, we are discussing about the centrifugal casting process. Centrifugal casting process basically an expendable casting process, or it can be used as a permanent mold casting process. So centrifugal casting process, there are three types: true centrifugal casting process, semi-centrifugal casting process, and centrifugal pressure casting process. So in this section, I have discussed about die casting process and centrifugal casting process. Okay.